So let's take a look at a problem that makes use of logarithms. So here's a problem that says solve for x to 4 decimal places, and the problem says 5 raised to the x power equals 4 raised to the x plus 1 power. So in previous problems you may have seen x raised to a power, but in this one it's a number raised to the x power, so the variable is in the exponent. So how do we solve such a problem? Well, we can't do it by dividing or multiplying, because that won't clear the x from the exponent, and we can't take the xth root of the problem as we could with saying x squared. So that won't work. So how do we solve this problem? Well, we have to make use of the idea of a logarithm. So let's take a look at actually a couple of approaches to this problem. Okay, so the first step we do, here's our first solution. We start with the original problem, and we take the logarithm of both sides. So the logarithm of 5 to the x equals the logarithm of 4 to the x plus 1. And as you see here, I'm using the base e logarithm, or natural logarithm, but you could equally use the base 10 logarithm, or the base 5 logarithm, or the base 3 logarithm, or any logarithm you'd like, as long as you're consistent on both sides. It just turns out that most calculators only have the natural logarithm and the common logarithm, that is the base e logarithm, or the base 10 logarithm, and so that's what we normally use. But anyway, let's continue. The next step is, since we know one of the laws of logarithms says that the log of some number to some power is that power multiplied by the logarithm of the number, we can make use of that law of logarithms and say this. We say that becomes now x times the logarithm of 5 equals the quantity x plus 1 times the logarithm of 4. That's pretty cool. So you can actually get the x's now out of the exponent by using the law of logarithms that says the log of a to the b is equal to b times the log of a. And that's what we did there. So pretty cool, huh? Alrighty, so let's continue now. And the rest of this is just straight algebra. Pretty simple algebra to get the x all by itself. And we'll go through that relatively quickly here. So first step is to distribute the x plus 1 into the logarithm of 4. So we say x times logarithm of 5 equals x times logarithm of 4 plus 1 times logarithm of 4. That's just the distributive property. And then we say, now let's get all of the x's to one side. So we now subtract x log 4 from the right-hand side, bring it over to the left-hand side, make it a negative. So it becomes x log 5 minus x log 4 equals log of 4. And then we again use the distributive property to pull out the x's here, and that becomes x times the log times the quantity log 5 minus log 4 equals the log of 4. And then I think you can guess the next step, and that is to divide both sides by this quantity, log 5 minus log 4. And that's what I've done right here. And when you do the calculations, you got to be careful that you use parentheses on your calculator when you're doing this part, this denominator part. Otherwise, most calculators will think that you've done the division of log 4 over log 5 and then subtracted the log of 4 from that. So you got to be careful and use parentheses. So it would go something like this. You would say 4, logarithm button, divide, open parenthesis, 5, logarithm, minus 4, logarithm, close parenthesis, and then hit the equal sign. And that should give you the following answer. X equals 6.21256743 901078, blah, 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 and depending on how many places your calculator has. And so there you go. And then the problem said to round it to 4 decimal places. And so we count off 1, 2, 3, 4. So we went around it to this place here. But since the next number is greater than 49, the next two numbers are greater than 49, we round up. And so the answer is that x is approximately equal to 6.2126. So that's how you get the answer to that problem. So pretty cool, huh? Now let's take another look at this, and I'll make a statement here, and that is that, depending on who you are, everybody's mind works a little bit differently, and you may think about problems in a different way. You may start with one thing and then go to another, and someone might do it the reverse way. The thing is that's fine. You can do the problems in a number of different ways and get the same answer. And here we'll show that. So here's another approach. So we start with this, but now we want to get the x's to one side, not by doing the logarithm laws and then subtracting, but here we're going to start off and simply divide both sides by this right-hand quantity, 4 to the x plus 1, and get this. 5 to the x divided by 4 to the x plus 1 is equal to 4 to the x plus 1 divided by 4 to the x plus 1, or 1. Simple. Okay? So we simply divide both sides by 4 to the x plus 1 and get this 5 to the x over 4 to the x plus 1 is equal to 1. Now, take the logarithm of both sides, and we get this. Logarithm of that division is equal to the logarithm of 1. And so you should think two things now. You think, well, how am I going to evaluate this? And there's a law of logarithms for that will hold for just, we'll do that in 2 more steps. But let's look at this side, the right-hand side. What is the logarithm of 1? Well, the logarithm of 1 is, what is it? It is 0. That's right, it's 0. So the logarithm of this quotient is equal to 0. Okay, so now we've taken care of that. How do we do this left-hand side? And you probably just saw it. That's right. If you have the logarithm of a divided by b, it becomes log of a minus the log of b. So here we say this becomes the logarithm of 5 to the x minus logarithm of 4 to the x plus 1 is equal to 0. So we've now gotten this this quotient into a subtraction problem, and again, all of these laws of logarithms come from the laws of exponents, where if you have a number raised, or a variable like x to the 2 over x to the 3, it becomes x to the 2 minus 3. And so, since the logarithms really represent the exponents, this is what you get. So that's where this law of logarithms comes from. Okay, so then the rest of it becomes straight algebra, very similar to what we did before. I'm sorry, actually we do one more law of logarithms. We take the power law, which says the log of a to the b power is equal to b times the logarithm of a. And here we've done that twice, once with x log 5 and quantity x plus 1 times log of 4 equals 0. Okay, and then we use the distributive property. Now it becomes an algebra problem. You divide, or you distribute the x plus 1 here. You now bring this constant term over to the right-hand side, and it becomes a positive. Here it's a negative, and you bring it over here, and it's a positive. So now we have x log 5 minus x log 4 over equals logarithm of 4. And this is exactly the same as the previous problem. Use the distributive property to get the x all by itself. Divide by log of the quantity, log 5 minus log 4. And then carefully remember to using your parenthesis on your calculator, get this value. By the way, just a quick note about calculators. Some calculators use algebraic notation, and that's the one I spoke of before. Some use reverse Polish notation, and some use some other kinds of notation. So know your calculator, make sure you understand. But most calculators use the algebraic notation that I recited before. So you get this value, you round it to the fourth decimal place, and you get the approximate answer there that you see. So this is a cool problem that can only be solved uh, with logarithms. So or easily solved with logarithms. So there you go. There's an interesting problem. Probably if you saw that on a test, you'd you'd be worried that you couldn't get that. But here's a very simple solution. Actually, two simple solutions on how to solve that. So I hope you enjoyed that and have fun with logarithms.